Hi guys! Welcome sa Engineered Math Channel. Sa video na to ay tuturo ko sa inyo ang op-amps as integrator and differentiator. So kung gusto nyo itong matutunan, just keep on watching. Okay, so far, meron na akong series videos about op-amps at different op-amp circuits like inverting op-amps, non-inverting op-amps, summing op-amps, difference op-amps na gumagamit lang ng resistor as a feedback or input resistor. This time, ay tuturo ko naman sa inyo ang applications ng capacitor at inductor as feedback or input passive elements sa op-amps. Wherein, pwede nating matawag ngayon ang op-amp circuit natin as integrator at differentiator. Okay? So, dito pala sa video na to ay i-derive lang natin yung formula for the output voltage of integrator and differentiator using capacitor lang. Since in reality, hindi tayo madalas gumamit ng inductor as the input or feedback passive element sa isang op-amp dahil ito ay masyadong expensive at bulky. So therefore, doon tayo sa practical na ginagamit as passive element which is the capacitors and resistors to construct the integrator and differentiator op-amp circuits. Okay, so let's start with the integrator. So ano ba ang integrator? So integrator is an op-amp circuit whose output is proportional to the integral of the input signal. So from the word itself, integrator, ibig sabihin daw yung output daw ng op-amp natin na VO ay proportional doon sa integral ng input signal Vin. So yung magiging output natin ay integral ng input natin Vin and the constant of proportionality is the value of the RC constant which is denoted by the value given by the capacitor and the resistor. So, dapat tatandaan nyo na kapag integrator, yung feedback element nyo ay yung capacitor at yung input element nyo ay resistor. So, for example, kung meron kayong square wave as input, so ito yung Vin, therefore, ang magiging output nyo yan, kapag dumaan na siya sa integrator, ay parang magiging integral ng square wave. So, ang integral ng square wave ay triangular waveform. So, like this. At it depends yung amplitude noong triangular waveform natin doon sa RC constant base doon sa ginamit nating value doon sa feedback tsaka input passive element na RC. Okay, so ngayon, i-derive natin yung formula for the output voltage for the integrator. So gamitin natin dito yung concept of ideal op-amp. So 'di ba sa ideal op-amp, meron tayong key equation na V minus is equal to V plus as well as I minus is equal to I plus is equal to 0 or wala tayong current na dumadaloy dito sa portion na to kasi yung impedance niya ay mataas. So kung i-apply natin yung nodal analysis, we have summation of current is equal to 0, let's say at node V minus so dito. So therefore, current leaving is equal to current entering. So, inassume ko na yung mga current dito sa resistor tsaka sa capacitor ay nagli-leave dito sa node V-. So, therefore, kung isa-sum up natin yung mga current leaving, so we have the current leaving as IR plus IC equals the current entering, wala na. So, therefore, equal yun sa 0. Now, i-represent natin yung mga currents in terms of the voltages at yung mga resistance at capacitance. So, for IR, it is equal to higher potential V minus lower potential V in over resistance R using Ohm's law. Plus, this time, we know on my video about capacitor that the current is equal to ICV dt. So, therefore, we can represent it as C times the derivative of the voltage drop across the capacitor. But seeing on this figure, if we apply the nodal analysis, we can see that the voltage across the capacitor will be V minus VO by applying the lower potential minus the higher potential. So therefore, we can represent current as C times the derivative of V minus VO over dt. And then equal to 0. Okay? Next, this time, ma-apply naman natin yung key equation for ideal op-amp na V minus is equal to V plus. Which is, yung V plus kasi natin, di ba naka-ground siya? So therefore, V plus is equal to 0. And since V plus ay equal sa V minus, therefore yung V minus natin ay 0 din. Right? So since V minus is equal to 0, pwede nating isubstitute yung V minus na 0 dito sa nabuo nating equation. So we have 0 minus V in over R plus C derivative of 0 minus VO over dt is equal to 0. Or simply, negative V in over R plus CD of negative VO over dt is equal to 0. So, itong negative VO, pwede nating ilabas yung negative niya. So, parang magiging negative V in over R minus C dVO over dt is equal to 0. Now, transpose natin itong C dVO over dt sa right side. So, we have negative V in over R is equal to positive C dVO over dt. Pwede nating i-divide both sides of the equation by C. So, we have negative V in over RC is equal to dVO over dt. Okay? Then, we can cross-multiply dt. So, we have negative V in over RC dt is equal to dVO. Now, para masolve natin yung output voltage, pwede nating i-integrate both sides of the equation with limits of 0 to t, which denotes that the starting time is 0 and the ending time is fixed at t. Dito sa left side of the equation, pwede nating ilabas yung constant na negative 1 over RC, then integral of V in dt from 0 to t is equal to, this time, pwede nating ma-integrate itong dVO, which is VO from 0 to t. Okay? So, we have negative 1 over RC integral ng V in dt from 0 to t is equal to, evaluate natin itong VO from 0 to t. So, we have VO of t minus VO of 0. So, we have VO of t is equal to, transpose natin ito sa kabila, parang VO minus 1 over RC integral of V in dt from 0 to t. Itong VO of 0 pala, siya yung initial voltage doon sa capacitor. So, pwede natin i-assume na initially 0 yung capacitor voltage. So, pwede natin itong i-neglect as 0. So, parang VO of t is equal to negative 1 over RC integral of V in dt from 0 to t. So, therefore, ito yung formula for the output voltage of integrator. So, mapapansin nyo, yung output voltage nga natin ay integral ng input voltage Vin. At yung constant of proportionality o numerical coefficient ay negative 1 over RC. Okay? Now, ito yung inductor version natin for the integrator. This time, yung feedback element ay resistor R at yung input passive element ay yung inductor. So, same form lang din to nung integrator natin kapag gumamit tayo ng inductor as passive element. Okay? Next, we have the differentiator. So, ano ba yung differentiator? So, sabi, a differentiator is an op-amp circuit whose output is proportional to the rate of change of the input signal. So, from the word itself, differentiator, yung op-amp output daw natin ay proportional doon sa derivative or rate of change ng input signal. So, i-derivative natin yung input signal para makuha natin yung output signal ng op-amp. This time, yung feedback element natin ngayon ay resistor at yung input element natin ay capacitor. Okay? So, halimbawa, kung meron tayong input dito na triangular waveform, kapag dinaan natin yung input na to sa differentiator, op-amp, yung output niya ay magiging square wave. Kasi, i-differentiate nung op-amp yung input natin na triangular waveform. So, kaya sa output ay magiging square wave. Wherein yung amplitude ng square wave natin ay nakabase doon sa value nung RC constant natin. Base doon sa value nung resistor tsaka capacitor natin. Okay? Now, i-derive natin yung formula for the output voltage kapag gumamit tayo ng differentiator. So, apply uli natin yung ideal op-amp key equation. So, V minus is equal to V plus is equal to 0, or I minus is equal to I plus is equal to 0. So, summation of current is equal to 0 at node V minus. So, assume ko ulit na yung current na dadaloy mula dito sa node V minus ay palayo. So, let's say itong sa resistor, sorry, IR to, palayo, and then itong sa capacitor, IC palayo. So, we have current leaving, summation of current leaving is equal to summation of current entering. So, yung mga current leaving ay yung IR plus IC. And then, yung current entering ay wala sa 0. So, we have IR, again, V minus VO over R. Plus, this time itong IC ay C D V minus V in over dt is equal to 0. Again, since yung V plus natin ay naka-ground, it is equal to 0. And at the same time, it is also equal to V minus, so therefore, V minus is also 0. So, pwede natin i-substitute yung 0 dito sa mga V minus natin sa nabuo nating equation. So, we have negative VO over R plus C of D negative V in over dt is equal to 0. Tapos, itong negative ng V in natin as constant negative 1, pwede natin ilabas na lang sa parang negative VO over R minus CdV in over dt is equal to 0. Tapos, transpose natin to sa kabila. So, so tuloy ko dito magiging negative VO over R is equal to positive na CdV in over dt. So, we can multiply both sides of the equation by negative R. So, we have VO is equal to negative RC dV in over dt. So, therefore, this is the equation for the output voltage of differentiator. So, mapapansin nyo, tama na yung output voltage natin ay derivative ng input voltage natin na Vin. At yung constant of proportionality ay yung negative RC. Okay? By the way, ito pala yung inductor version natin for differentiator. This time, yung feedback passive element natin ay yung inductor L at yung input element natin ay resistor. Okay? Now, let's solve some examples to illustrate the formula that we have derived for the differentiator and integrator of amp circuits. So, we have, if V1 is equal to 10 cosine 2t millivolts and V2 is equal to 0.5t millivolts, find VO in the op-amp circuit below. Assume that the voltage across the capacitor is initially 0. Okay, so this time, yung configuration natin ay summing integrator kasi meron tayong dalawang input. So, pwede natin apply dito yung formula natin for integrator. Kaso, kailangan dalawa yung magiging factor natin ng 1 over RC integral of V in dt. So, parang ang magiging output natin ay, let's say ito yung R1, ito yung R2. So, parang ang output natin ay i-add natin yung dalawang integral nitong input na to. So, parang negative 1 over R1C integral of V1 dt minus 1 over R2C integral of V2 dt. Tapos, since daw yung initial voltage naman daw dito sa capacitor ay 0, yung V0 natin ay 0. So, kahit hindi na natin ilagay dito, i-add dito kasi 0 naman. Okay, so substitute natin ngayon dito sa formula. So, we have, anyway, dapat ito ay from 0 to t. From 0 to t. Okay, so we have negative 1 over R1 is 3 times 10 raised to the 6th ohm times yung C natin ay 2 times 10 raised to negative 6. Then, integral of, yung input 1 daw natin, yung V1 ay 10 cosine 2t. So, 10 cosine 2t minus 1 over, this time yung R2 natin ay itong 100 kilo ohm. So, we have 100 times 10 raised to the third power. And then, yung C natin ay 2 microfarad pa rin. So, times 2 times 10 raised to the negative 6 integral from 0 to t of, this time yung V2 natin ay 0.5t millivolts. 0.5t. Okay? Ngayon, simplify natin. Integrate natin. Ano yung integral netong 10 cosine 2t? So, itong 10, pwede nating ilabas. Tapos, ang integrate natin itong cosine 2t. So, obviously, ang integral ng cosine ay sine. Kasi meron tayong 2, so parang magkakaroon tayo ng over 2. So, parang negative 1 over 3 times 10 raised to the 6 times 2 times 10 raised to the negative 6. 10, nilabas ko yung constant na 10 over 2 para to dun sa 2 ng cosine 2t. And then, magiging sine 2t na siya. Okay, so review lang ng integral calculus natin. Minus, dito naman sa integral ng 0.5t, ito, constant lang. Tapos sa t, gagamitin natin yung power formula na t raised to n, integral niyan ay t raised to n plus 1 over n plus 1. So, parang magiging, ito na lang, negative 1 over 100 times 10 raised to the third times 2 times 10 raised to the negative 6. Yung 0.5 ilalabas ko, then integral ng t to the first power yan bale. So, t squared over 2. Okay? So, using calculator, masasolve natin tong mga constant na to as, so itong unang constant ay equal yan saan? Negative 0.833 sine 2t. And then, itong pangalawang constant, equal yan saan? Negative 1.25t squared. So, the unit is millivolt. So, therefore, this is the output of the summing integrator. Okay? Next, we have sketch the output waveform for the circuit below. Given the input voltage in figure below, take V0 is equal to 0 at T is equal to 0. Okay, so obviously, itong op-amp circuit natin ay differentiator kasi may feedback resistor tayo tsaka input capacitor. So, hanapin daw natin yung output waveform given this input waveform. So, ang first step ay identify muna natin kung ano ba yung representation ng input voltage natin base dito sa graph. So, hanapin natin yung equation ng graph. So, ito ay input. Okay. So, para mahanap natin yung equation ng waveform na to, mapapansin nyo, periodic siya. So, ito yung first period, tapos naulit lang dito sa pangalawang cycle. So, pwede lang natin hanapin itong piecewise functions nitong dalawang graph na to, which is just a line. So, gamit tayo ng piecewise function. So, dito muna sa line na to. So, for the interval, t is in between 0 to 2 millisecond, ano yung equation ng line na to? So, obviously, pwede natin gamitin yung 2.4 yung y minus y sub 1 is equal to m times x minus x sub 1. This time, yung y natin, yung v, so v minus v sub 1 is equal to m times, this time yung x natin ay t minus t sub 1. So, ano yung dalawang point natin? Itong, di ba 0, 0, tapos 2, 4. Itong 2 millisecond yan. So, so, hanapin muna natin yung slope. Slope is m is equal to v2 minus v1 over t2 minus t1. Let's say ito yung point 1 natin, ito yung point 2. So, parang 4 minus 0 over 2 times 10 raised to negative 3 minus 0. Or we have simply 2,000. So, therefore, kapag sinubstitute natin dito sa formula na to, meron tayong v minus, pili tayo ng isang point, 0 na lang. So, itong 0, 0. V minus v sub 1 is 0 is equal to m na 2,000 times t minus 0 pa rin. So, we have v is equal to 2,000t. So, ito yung equation ng waveform natin. At duration, 0 is less than t is less than 2. Okay? So, inclusive to. So, we have v1 is equal to 2,000t. Okay? So, sulat ko dito, v in is equal to 2,000t when t is in between 0 and 2 millisecond. Next, para naman dito sa graph na to, gamitin uli natin itong equation na to. So, we have 0.1, let's say itong 2, 4. Tapos itong 0.2, this time itong 4, 0 na. So, we have M nila ay, let's say ito yung 0.1, ito yung 0.2. So, rise over run. So, V2 minus V1 is 0 minus 4 over 4 millisecond minus 2 millisecond. So, we have negative 4 divided by 2 times 10 raised to the negative third power. Or simply, negative 2,000. So, therefore, yung slope niya ay negative 2,000. Now, apply na natin yung formula for the final equation for the second line or the V2 natin for the input voltage. We have V minus, so pili tayo ng isang point. Ito na lang 4, 0. So, V minus V sub 1, which is 0 here, is equal to yung slope natin na negative 2,000 times T minus yung T1 natin na 4 times 10 raised to negative 3. So, we have V is equal to, distribute natin itong negative 2,000, we have negative 2,000T plus 2,000 times 4 times 10 raised to negative 3 is simply 8 na lang. So, positive na kasi negative times negative. So, therefore, ito na yung V sub 2 natin for the input voltage. 8 minus 2,000T. So, ito yung lalagay natin dito sa second subfunction nung input natin. 8 minus 2,000T for 2 is less than or equal to T is less than or equal to 4 millisecond. So, therefore, ito yung gagamitin nating equation for the input voltage para dun sa differentiator natin pag hinanap natin yung output voltage na negative RC dV in dt. Okay? Now, ang next step ay apply na natin yung formula for the output of differentiator, which is yung VO is equal to negative RC dV in dt. Okay, so dito muna tayo sa first subfunction natin. Ang gagamitin natin ay 2,000T for the interval na 0 is less than T is less than 2 milliseconds. So, we have VO is equal to, so pag sinubstitute natin to, negative RC, so ano yung R natin? 5 kilo ohm. Tapos yung C natin, 0.2 microfarad. So, 5, so we have negative 5 times 10 raised to 3 times 0.2 times 10 raised to the negative 6. Tapos yung derivative ng input natin, this time, dito muna tayo sa 2,000T. Anong derivative ng 2,000T? 2,000 lang, right? So, we have times 2,000. This is, so delete ko na to. This is for the interval 0 is less than or equal to T is less than or equal to 2 milliseconds. So, using calculator, masasolve natin yung value na to as negative 2 volts. So, equal to sa negative 2 volts. Next, doon naman tayo sa second sub-interval, 8 minus 2,000T. So, ganun pa rin, negative RC, which is negative 5 times 10 raised to the third times C is 0.2 times 10 raised to the negative 6. This time, derivative nitong 8 minus 2,000T. So, parang 0 naman derivative nito, tapos derivative ng negative 2,000T, negative 2,000. So, para 0 minus 2,000 or times negative 2,000. So, therefore, negative lang nito, which is equal din sa positive 2 volts na. Okay? Kasi negative times negative is positive. This time, yung interval ay 2 is less than or equal to T is less than or equal to 4 millisecond. So, therefore, ito na yung magiging output nung differentiator natin. So, pwede na natin siyang i-graph. So, piecewise function lang din siya. So, meron tayong value na positive, negative 2 volts for interval 0 to 2. So, 0, 1, 2, 3, 4, 5, 6, 7, 8. So, dito yung 0 to 2, right? So, ang value niya ay negative 2. So, dito, 1, 2. So, from 0 to 2, negative 2 yung value niya. Constant function. And then, from 2 to 4, magiging tatalon siya sa positive 2 volts. So, parang nandito siya. 1, 2. So, dito na siya. Okay? From 2 to 4. Okay? From 2 to 4 to, diba? 1, 2, 3, 4. So, tumalon siya. And then, repeated lang yon kasi periodic yung input natin na triangular. So, parang babalik uli siya dito sa negative 2 from 4 to 6. Tapos, papanik uli siya dito sa 2 from 6 to 8 and so on and so forth. So, therefore, napansin natin na totoo yung naging application ng differentiator. Dinifferentiate ng op-amp yung input niya na triangular wave, kaya naging square wave yung output. Okay? Okay, so I think that's it for the video of amps as integrator and differentiator. So, sana ay may natutunan kayo sa video na to at maraming salamat sa panonood.